All right, guys, I seem to have gotten everything back and finally running at a good pace. I'm sorry for the delay. For whatever reason, everything wouldn't work on my computer, so I just did, of course, what everybody tells you to do. Shut it down, restart it. All of a sudden, everything seems fine. So yesterday we finished class with a couple questions. I rewrote the same directions, but I do have 3 different examples that I am going to go through, kind of show you why they work the way they do. And again, this part's just review. So first thing I'm going to start with is I need to remember, it says determine whether the triangles are similar. That is our first question. Once I recognize what the first question is, I want to also recognize that it does say if so. If we see that word if so, we are going to make sure that we remember that it could be no. They might not be similar. I do need to take into account that I have to write a similarity statement, and I also need to make sure that I show my explanation so that I make sure that I have everything that I'm supposed to have answered by the time I'm done with the question. So the first thing that I am looking at is this bow tie shape, and of course every time we see this bow tie shape, we want to make sure that I remember I have vertical angles. But I also want to remember that what I'm looking at has numbers. So in this question, if I look, I have a 10, a 4, and a 12, and a 5. So that means if I'm going to take a guess as to what's going to be used, I'm going to probably use side angle side. Hey, Donnie. Side angle side because I only have 2 sets of sides, not all 3, so it can't be side, side, side. And I'm going to have to use these angles. So the first thing I'm going to do is I'm going to put these tick marks in so that I know that I have vertical angles, and I am going to say angle ACB is congruent to angle DCE, and I am going to give my reason. Vertical angles are congruent. So we are one step into what we think, hey Caitlin, what we think is side angle side. Now, the other thing that I have to do here is if it is side angle side, I need to make sure that I match up the correct pieces. Don't forget that we have smallest goes to, or I should say shortest goes to shortest, longest goes to longest. So if this is supposed to be side angle side, I'm supposed to compare 10 to 4. Is that equal to 12 to 5? And what we find out is even if I do use my calculator, again, I'm not sure if you can see that, but if I divide 10 divided by 4, that's only 2.5. 12 divided by 5 is 2.4. So what we end up with is even 2 decimals that don't match. So all I'm looking at is right now 2.5 and 2.4 aren't equal. They're close, but they're not equal. Hey, Allison, I hope you guys are having a good day. So that means these are not in proportion. So then my final answer here is triangles aren't similar. It looked like side angle side. So my final answer here is triangles are not similar. And we're done. This is our explanation. Here's our final answer. Daniel, Mr. Webb, how are you guys doing today? Hope everybody's at least got outside a little bit this morning when it was still warm. So let's take a look at example 2. I am going to tell you I set this up to be side angle side, so we're going to talk about that. And then I was told earlier today there was a much faster and easier way. So in this picture, the first thing that I want to recognize Just so is the screen shaking or is it just having a trouble buffering, Caitlin? Because from my end, things are working okay. Hopefully it will record okay. This is an isosceles trapezoid. So because it's an isosceles trapezoid, this guy and this guy will both be 4. This guy and this guy will both be 12. So it ends up allowing us to see that the triangles that I really want to look at are these guys top to bottom. I don't know how to fix that. Well, let's hope. I should be done soon. I'm sorry, guys. So with that, I can see that I do have vertical angles here. So if we're working with this, we have angle WPX is congruent to angle YPZ, and that's because those are vertical angles. So then what we have to check, because that works, is again we see that they're going to have 2 sets of sides, very similar that we had over here. So now let's go ahead and check to see what about our sides. And we can see that we have 4 to 12, which would be equal already to 4 to 12. So it checks out for both of them. Sides proportional. And right away, this is enough. We've gone ahead and said that because we have vertical angles, because our sides are in proportion, they happen to be identical, 4 to 12, 4 to 12. Yes, similar, and we can go ahead and say triangle WPX is similar to triangle YPZ, and we're done. We've explained, we've said yes they are, and we've listed our similarity statement. Now, there is a faster way, and I didn't even consider it earlier, but you could have stated that because it's a trapezoid, the sides are parallel. So those bases top to bottom are parallel. And we could have proven this by angle-angle similarity, since we would have had alternate interior angles congruent as well. So it was possible that we could have done it by angle-angle, because we also get alternate interior angles here and here, or here and here, and that's because our trapezoid has those alternate interior angles. Okay, so the last thing on here is actually much faster, but again, I know that I received some questions just to make sure that we understood how to explain. This is as fast as the explanations can go, so just make sure that you are looking at all of the steps that I'm trying to include and why, and of course, color coding them. So far, are there any questions? I'm going to get you guys moving up. a little bit so you can see the other one. And if you are copying as we're going, does anybody remember what kind of angles are actually in this example? And I suppose the other question I could ask is, do you know if there is a possibility for these to be similar? What's the only way we could possibly say these are similar? We talked yesterday about there's pretty much real big clues that tell us how we would know triangles are similar. So in this case, for those of you that are with me today, how could we say those are similar? All right, not sure. So what we're going to look at is we don't have any side lengths listed, and that's going to be the dead giveaway here. If you take a look, we don't have side lengths. So if that's your question, why don't we? We don't need them for similar. What I'm looking at here is I could say angle G is congruent to angle G, and that's our reflexive property. It's in both triangles. And then we have these parallel lines here that allow me to say these two angles are congruent, and for the exact same reason, those two are congruent. Does anybody know how those two sets of angles would be congruent to each other? Angle GHK congruent to angle I, or angle GKH congruent to angle J. It's the same reason. As I'm waiting, I want you guys to know there are no right angles here, so we've got to be real careful. It looks like they're supposed to be, but there are no right angles. Anybody want to take a sigh of relief? We were just informed. Thank you, Caitlin. We were just informed your EOC tests will not be taken this year. Which is a huge sigh of relief, not just for you guys, but for us as well. Yep, we do have this up here. Thanks, Paige. And then we have our corresponding angles right here. Yep, I agree. I'm really excited for you guys for that. Obviously, I'm not sure how they'll handle that, how they'll deal with that, if they'll just say none at all, or if there's something that they'll put in place of it. Let's God forbid that. That makes no sense. But I'm really excited for you guys that you only have to worry now about making sure you get your work done and passing the class, and you don't have to stress over that. That made my day when I saw that this morning. It's on Twitter as well, if you guys follow Mr. Pempen. So any two pairs of these angles make this angle-angle similarity. So the fact that it is angle-angle similarity, and then we would simply say, now here's again where you might benefit from, after you see these tick marks, separating these two triangles, keeping the tick marks the same so that you can follow your pattern when you list them. Again, this is a really good habit to get into. Now we can call this GHK is similar to GIJ. And we're done. So let's see. Do you think that we are going to have to take it next year? How is online classes going for everyone? Hi, Nico. It's going better for me than I thought. And Caitlin, I couldn't imagine. I could not imagine that that they would. It would just be the most ridiculous thing I've ever heard of. That doesn't mean that they'll go away forever. I just don't know if they'll make you necessarily take geometry because of these just unheard of circumstances. So, I mean, that's logical. We all know that it's not always a logical decision when things are made, but yeah, there is no doubt that it would be very difficult for most students to retain that kind of information over the summer. So who knows, but please, what this doesn't mean is stop trying to retain that information. That just means take a breath of a little bit of a relief there. But yeah, Mr. Pempin put that on Twitter today, I saw. So, all right, I am going to move forward now that we kind of see what we're supposed to with these questions. And we have just 2 more, and then we are done for the day. I did put on your accounts already. I'm going to zoom out for a minute so that you can kind of see what we're looking at. I did already put on your Google Classroom some updates, so please keep that in mind as I go to take a look at what I posted while you look at those. I did post what your assignments were. I have that the no-re account assignments, 8.1 and 8.3. Many of you are doing an amazing job. I'm so ridiculously happy, and I hope it doesn't sound corny, but really proud of so many of you working on the 8.1 and 8.3. I did load 8.4, and I did put already just a quiz that I would have given today had we been in school. It is, again, not something that is required, but it is something that you can kind of see, are you doing what you should be doing to be where you should be at this point? Again, I think more of us, thank goodness, have gone to online means of communicating with you guys, and I did say yesterday I would probably look to doing Zoom once a week at the same time, so instead of a live stream, we would Zoom. That's at least my hope. I'm still working out some kinks, but always check Google Classroom. All right, so to help you with some of your online questions and practice quiz questions, it says identify the similar triangles. Why are they similar? And then find, and let's finish this, the measure of x. That way it makes a little bit more sense. First off, I'm going to pay attention to the fact that we do have parallel lines that are really obvious in this. So anytime I see parallel lines, I am going to concentrate on these Z shapes that will always show up in our bow tie shape. And probably the fastest way to identify these are similar by angle is because of those alternate interior angles. So angle L is congruent to angle P. Angle M is congruent to angle R. Alternate interior angles are congruent, which means these are similar by angle similarity. Hey, Brendan. I should make sure you tell your sister my daughter says hi. She keeps bugging me. She wants to get everybody's cell phone number so she can sit around and talk on the phone all day. I'll have to tell her you stuck by. So we have our angle similarity. And it does say, why are they similar? So we have that, but this identify is something that is very important because if we don't know which 2 triangles are similar, we can't match up our proportion. So I said L to N to M. So I am going to name this P to N to R so that I do follow the same tick mark pattern. This allows me then to take a look and say, okay, if I have LM, which is first and last, what will that correspond with? And that's PR, which is first and last. I see LN is also listed here, so I'm going to write that, and I'm going to check to see if LN is first and second. I'm going to match that with PN because that's first and second. And because I know what that similarity statement is, I can set up my proportion the right way. Taylor, I know that totally makes sense because I immediately wondered that as well. I'm wondering if they're either going to adjust those points for your graduating class specifically, which again is a headache for our guidance counselors, our school counselors, because that's just another way to have to keep track of everything. And that's across the state, not just ours. Or if instead of changing your total, we'll award you those points. Again, I think that all makes sense. Goodness knows that that doesn't necessarily mean that's what's going to happen, but I'm just guessing at this point. So LM, the length of that we know is x plus 3. PR we know is x minus 1. LN is 18. And PN is 12. And then we're going to cross multiply. Don't forget when we cross multiply that those are quantities. We need to make sure that we account for those. So this is actually going to be 12 times x plus 3 and 18 times x minus 1. And when we distribute now in both cases, we have to make sure we don't forget to carry it to that second guy. So we have 12x plus 36 equals 18x minus 18. So I am going to subtract 12x from both sides. And that leaves me with 36 equals 6x minus 18. We're going to go ahead and add 18 to both sides. And we end up with 54 equals 6x. So when we divide, we end up with x equals 9. Now, again, if it would have told us to find the length of a side, like find the length of LM or find the length of RP, we would definitely have to plug that in. Again, if you have questions, just ask. So now, as we look at the last question for the day, again, we've got these parallel lines, but our transversals are off to the side. So we can see that we have these parallel lines. Our transversals, however, are off to the side. And I won't draw them both because then all that looks like is I'm redrawing the triangles. However, what I end up with here are corresponding angles. And those are always congruent if our lines are parallel. We do have our reflexive angle here, and as long as I know that I have those corresponding angles, we can see that they are similar. And we have our reflexive property, which we know that they are similar by angle-angle similarity. So again, I need to still figure out I have to identify the similar triangles, so I need to make sure that I still do that. So my suggestion as I zoom in here is separate these triangles now by using your tick marks as a guide. If I separated these triangles, I have the larger one that is A to E to C, and it has this tick mark, that tick mark, and this guy. And it does tell me that E to C is 24. And then I end up pulling out the smaller one, which is B, D to C. And if the whole thing was 24 and I already have 8, 24 minus 8 leaves me with 16. And I have the 6x plus 2. Can anybody tell me, of those of you that are paying attention, how do I find AC? We were given EC was 24 and we subtracted to find 16. My question is, how do I get all the way from A to C so that I have the corresponding side for 6x plus 2? Or does anybody know what that's going to be? Yep, we are going to add x plus 5 and 6x plus 2. So when we do that, this guy right here, and I'm going to kind of arrow him in a little bit. This is our segment addition postulate, where we are going to take our x plus 5 and we're going to add that 6x plus 2. So we are going to, and I know I have my hand over it, I'll move it here in a minute. That's our segment addition postulate. We're going to add those guys together. So x plus 5 plus 6x plus 2, and we end up with 7x plus 7. 7x plus 7. So by separating the triangles, we were able to show how our tick marks are in here. We are able to match our triangles now so that we can write our similarity statement. So I am going to name this guy ACE is similar to BCD. So triangle ACE is similar to triangle BCD. And that makes it a lot easier once I have that guy. We identified him. We know that that's something that we need. And now I can do my proportions again. So when I match up AC, I can see that AC are the first two, BC are the first two. I'm just looking now at this because I've done the hard work with that. I'm looking at EC is our last two. So our last two, if it's CE, our last two is CD. And now we can plug in our values now that we know what's supposed to match. So AC is 7x plus 7. BC is 6x plus 2. EC is 24. And DC is 16. Now, you can cross multiply. You can go ahead and immediately solve. If you're looking for mental math, 24 over 16 and trying to cross multiply with those big numbers could get a little troublesome. So you can always reduce if you want to, and that would then turn this into 7x plus 7 over 6x plus 2 is equal to divide everything by 8, and you end up with 3 over 2. And that way now, if I had to, the mental math is a little bit easier. And with the mental math, I can cross multiply, and we end up with 2 times our 7x plus 7 and 3 times our 6x plus 2. So this ends up being 14x plus 14 equals 18x plus 6. I'd subtract our 14x. I'd subtract our 6 to the other side. And we end up with 8 equals 4x, so x equals 2. Now, the biggest takeaway from this is be able to say why we were able to identify them as similar. We want to make sure that we know that it's angle. We want to make sure that we can write our similarity statement. Without our similarity statement, we might be unsure as to how to do the proportion. Make sure we recognize those concepts from the beginning of the year where we have that segment addition postulate where we are adding them together to get that value. And don't forget to still distribute when we multiply. So those are just the examples that I have. I don't have anything else for you today. I'm going to wait a couple seconds here because I know there's a 20-second delay. If you have any questions, please feel free to ask. I know that when I get them on my email, I send you guys the PDF of everything so that you are up to date. And please check Google Classroom. I have a feeling I'm going to be very busy this weekend, trying to contact people who I can tell are not doing the things in the NORI account that we are all capable of getting into. I am not doing Alex because I don't want to have to worry about people having the excuse that they can't log in. I know we're all able to log into the NORI account, and there is no reason why that can't happen. So please make sure that you are checking Google Classroom so that you know exactly when things should be due. I will also make mention that the administration is contacting us to make sure that students are doing their work. And I have been asked specifically if people are not doing their work, some specifically students, not just in general. So get out there, spread the word, make sure they check Google Classroom, continue to email me. I check all the time. And as soon as I can get answers written out and your questions taken care of, I always email back, and then I post stuff again to Classroom to keep everyone on the same page. All right, guys, it doesn't look like we have any questions. I thank all of you who showed up. If an Alex problem, if the Alex lesson was finished, or if you choose to finish the Alex lesson that I loaded, I will offer extra credit. I will also post that. I'm going to write a reminder for myself right now, but I don't want anybody to think that if they did complete the Alex lesson that I did load, that I would offer that guy as extra credit. We're going to stick with NORI, and that way everybody's confident that they're getting all the information. So thank you, Xander. So we are not doing, I am trying to catch up on the NORI. Absolutely. And that's why I said the NORI, I'm giving you kind of benchmark dates. Don't put them off for too long, but you can do some problems and then come back to them. I believe that's how it works. At least I can see. So yeah, work on the NORI. Make sure you continue to check Google Classroom, and we should be good. Have a great afternoon, everyone, and get some rest this weekend, but continue to stay focused.